Alrighty, let's do part B. Oh, that little there. Let's do part B of this exam. Again, let's put our name here. Oops, on that. There you go. Okay, so first multiplication question. The point where the line 3 with y equals 3 minus 2x intersects the line y equals x minus 3 is which one of these? The best way of doing this is we can try and solve the equations, set them equal to each other. So 3 minus 2x, if that equals y, and y also equals x minus 3, that means that the two of these must equal each other. We can get rid of that, and we're trying to solve that equation. So if I take the 2x to the other side and I bring the 3 across, I get 6 equals 3x. If I bring that 3 across that side and that 2x goes that way, and that which means x equals 2. If x equals 2, it's either b or e, so the best way to do is just to plug it into one of these equations and see what we get. Y equals 2 minus 3 equals negative 1, and if we put it into the other one, 3 minus 4 is also negative 1. So our answer is definitely B. Second one, adding which pair of simultaneous equations will eliminate y? So if we were to add these two, we'd have negative 5 plus negative 5, which is negative 10. That's no good. These are definitely no good because their coefficients are different. These are no good because, again, if we add 5 and 5, we get 10. These are no good because their coefficients are different. This is the one that we want because if you check it out, negative 2y plus 2y is 0y, and that will eliminate the y. So the answer to that one is E. Question 3 says the shaded half plane represented in the diagram above is represented by, and this is one of those ones similar to the last paper where we can play, so I'll zoom out a little bit, play the game of what are these two rules. So the first rule, the solid line rule, is with a y-intercept of negative 2. So y equals and a gradient of a half. Not sure how quickly you guys can see that, but for every step across, we go up by just half a unit. So 2 steps across is up by 1 unit. Rub that out so we don't lose too much of that. So that's the first line, and the second equation is y is x minus 3. Again, gradient of 1 and y-intercept of negative 3. So from that, now that we've got those two, now it's just about working out what signs we've got to have. So again, like I did the last time, I'm actually going to remove the signs out of these. I'm actually going to remove that half x and put it in a sensible position, like that, and put some signs in. Now both of them, the region is below the line, so all of the y values are either equal to what the equation says or less than. So for the red line, it'll be less than or equal to and less than. Because both the region we want is underneath both the red and the blue lines. Again, this type of question I don't want you to stress too much about, but our answer is going to be E by the look of it. Where are we? No, it's going to be, oh, I've got my little lines the wrong way around. This one is supposed to be less than or equal to, because that's the red line. The top one is the red line, this is the blue line. So that one being dotted needs to be like that, which means the answer that we want is B. I'm going to actually do it properly. B. There. All right, next one, question 4. There's question 4 on, there it is. For some reason I'm losing my question 4. Jumping straight to 5. There's 4. Okay. Right. A pair of simultaneous equations has been solved simultaneously to give a solution 2, 3. The two equations could be what? The best way to do this is to substitute 2, 3 into each of these equations, and basically the one you're looking for is the one where 2, 3 works with both. So 2 plus negative 3 is negative 1, so that's a tick, but you'll see that this one's a false. 4 minus negative 3 is in fact 7, so A is not the answer. B, if we go 3 times 2 minus 2 times 3, plus 2 times, what's going to end up being minus 2 times negative 3 is 6 plus 6, so that one satisfies. And 2 times 2 is 4, plus 3 times negative 3 is negative 5. That one satisfies, we found it. B. I'm just looking for the point where basically the idea of that question is to, if we get back up, is to find the situation where both the equations are satisfied by 2, -3. Rightio, next one. Question 5, last one. 12,000 tickets were sold for music festival. Total receipts from ticket sales were 1,250,000. There were two classes of ticket, standard and premium reserve. Standard entry ticket cost 100 and premium 120. How many premium tickets were sold? So 12,000 tickets. So if we call S the number of standard tickets and P the number of premium tickets, then S plus P has to equal 12,000 because there was 12,000 tickets sold. That's in the first sentence. And the second sentence says the amount of money made, which is going to be 1,250,000. Make sure I got the right number of zeros there. Is going to be $100 for every standard ticket plus $120 for every premium ticket. Now you can do this on Mathematica if you type in this capital S OLVE, then square bracket, curly bracket. I'm going to put the two equations in. So the first one is going to be S plus, no comma there. Let's get rid of that comma. No comma there. So S plus P equals 1,000 is 12,000, and 100S plus 120P has to equal 1,250,000. So then we would then close off that curly bracket and then have a comma. So that's the equations that we're solving, and comma, and the variables that we're solving for are S and comma P. Close that curly bracket and then close the square bracket. If you type that into Mathematica, or remember that Mathematica you need to have two equals in there. So there needs to be a double equals. That's a double equals too. Make sure you do double equals there, and Mathematica will tell you what S and P are equal to. Okay. Where no specific method of solution is indicated, use whichever method you feel is appropriate. So you can do substitution, elimination, however you want. Okay. So the larger of two numbers, where did it go? The larger of two numbers is 4 times the smaller, and their sum is 85. Solve algebraically to find the two numbers. So the larger of two numbers is 4 times the size of the smaller one. So we'll call the two numbers L and S, where L is the larger one and S is the smaller one. So the larger one is 4 times the smaller one. So 4 smaller ones equals 1 larger one. And they add up to 85. So S plus L equals 85. Now for this method, I'm going to go with substitution. I'm going to substitute in 4S for L to get S plus 4S equals 85, which means S 5S, my 5s and my S's look similar, but anyway, 5S equals 85, which means S equals 17. So the smaller number is 17, so that means the large number is 4 times 17, which is 4 17s, what's that, equal to 68. So the two numbers are 68 and 17, which makes sense. They both add up to 85. Beautiful. The setting up of the equations is half the trick for these. The equations actually solved will be relatively easy. So margarine is sold either in 250 gram or 400 gram tubs. The supermarket manager orders 19.6 kilograms of margarine and receives 58 tubs. Two equations. Okay, so let's call the 250 gram tub the little tub, and we'll call the 400 gram tubs the big tubs. So these are the number of littles, and these are the number of bigs. So that we receive 58 tubs in total means the number of little tubs plus the number of big tubs is 58. And the weight of little tubs, so that's 0.250 times the number of little tubs plus the weight of the big tubs, 0.400 times the number of big tubs, has to equal a total of 19.6. Now it's really important that you get your units right. I've converted the 2 grams into kilograms in order to work this out. I could also, if I want to, turn the 19.6 into grams and go 250L plus 400B equals 19,600. That will work too. Okay, so once you've got this, again, this will be a Mathematica solve. You can do it by hand, multiply the first equation by 0.250 and do it by hand, but in Mathematica, capital S solve, square bracket, curly bracket, L plus B double equals 58, and 0.250L plus 0.400B equals 19.6. Close the curly brackets, and we are open a new set of curly brackets because we're finding L and B. Close it. That will give you the solution that you want. Make sure you remember the double equals, which I didn't there. Naughty me. Always remember double equals. How many 250-gram tubs of margarine did the supermarket order? So we did the two equations. That is going to give us the answer to this question. Next one, question 3. A rectangle has a perimeter of 32 centimeters. If 3 centimeters is taken from the length and added to the width, the rectangle becomes a square. Find the dimensions of the original rectangle. So if we were to get rid of that line, if we were to draw that rectangle, this rectangle basically says if 3 centimeters is taken from its length and added to its width, they would be equal. So, and let's call that width of the square x. So if that width of the square was x, then the original length is going to be x plus the 3 that I took off. And the original width will be x minus the 3, because then when I add 3, I get a square. So if I take 3 off this length and add it to this width, I will get a perfect square, which is x by x. So from this, the perimeter of this equals 32. So find the dimensions of the original rectangle. So the original rectangle, if it was a square, still has a perimeter of 32. So if that length that we don't know is x, so 4x equals the perimeter, which equals 32, which means x equals 8. Now if x equals 8, we can then go on and say that means that x plus 3 equals 11. A equals 8, which means x equals 5, and x minus 3 equals 8, which means x equals 11. So in this case, we're going to, what have I done there? What have I done there? Oh, look, that's the end of part B as well. What have I said here? X plus 3 has to equal, well, the long side is going to be 11 and the short side is going to be 5. So find the dimensions of the original rectangle. We've done that. And in fact, we didn't even need to solve simultaneous equations for that. We could just realise that the perimeter of the square is going to be the same as the perimeter of the rectangle, and the perimeter of the square being 32 means x is going to be 8. Each side is going to be 8. So if you'd taken 3 off a side and put it on another, the original lengths must have been 11 and 5. It's kind of a weird question, actually. It's a super easy one. Yeah, but mathematically, if we're going to solve that, let's get rid of this and let's just work out what this is. If x equals 8, then x plus 3, here we go, you have to annoyingly sit through me rubbing all these out. X plus 3 is 8, oops, that is 8 plus 3, which is 11, and this side is 8 minus 3, which is 5. That's actually all we needed to do. I way overcomplicated it. Something that we tend to do in mathematics. Oh, that's the end of the test. Good luck tomorrow, guys, and I will see you in class.